Assalamu alaikum wa rahmatullah. Dear students, I welcome all of you on my YouTube channel, which is regarding to educational videos, especially which will tackle the problems related to physics. आज की जो हमारी प्रॉब्लम होगी वो प्रॉब्लम होगी IIT JAM 2013 का एक क्वेश्चन which was asked on photoelectric effect. The reason why I am solving this problem first, because I saw this problem which was solved in some books. I will not name those books, but the question was solved by a wrong procedure, which was not a good procedure, and also the answer given at the end was wrong. So how to solve this question? First of all, we will know the question. Question was asked like this: electric field component of an electromagnetic radiation varies with time as. So we have given electric field component of an electromagnetic radiation like this, which was given as E is equal to A cos omega naught t plus sine omega t cos omega naught t. This was our electric field component. And also we were given omega is equal to 1 into 10 to the power 15 per second, and omega naught was given to be 5 into 10 to the power 15 per second. It's plus 15. So this was its angular frequency which was given, and the question tells us at the last, the radiation falls on a metal of work function 2 electron volt. Our work function is 2 electron volt, which is given. So this radiation falls on a material whose work function is 2 electron volt, and then it says the maximum kinetic energy in electron volt of photoelectron is. We have to say what will be the maximum kinetic energy of the photoelectron which will be emitted from this surface by this radiation. So we have to solve this question. So it's a beautiful question. If you see, this is here is we have given an equation, and we have the angular frequencies, two different angular frequencies, and we are given the work function of the material, and we have to solve what is the maximum kinetic energy of the photoelectron. See what is the procedure of solving this problem now. So we'll write these things here. Our omega is 1 into 10 to the power 15 per second. Omega naught is equal to 5 into 10 to the power 15 per second. And our work function is 2 electron volt. Now how to solve this question? See, the procedure is simple if you know the mathematical identities, trigonometrical identities. So how we can write this? We can write this as E is equal to A cos omega naught t plus A sine omega t cos omega naught t. So here this sine omega t cos omega t, we will use a trigonometric formula here, that is we can write it as A cos omega naught t. It is equal to A ऐसे ही रहेगा, it is half of sine A plus B. It is half of sine A plus B sine A minus B plus sine A minus B, half of sine A plus B, that is omega t plus omega naught t plus half of, और A इसमें भी multiply होगा, half of sine A minus B. A is omega t minus omega naught t. Now further we can write it like this: A cos omega naught t plus A by 2 sine omega plus omega naught. We will take this t out of the brackets as common, plus A by 2 sine, यहाँ पे भी हम t को common लेंगे, ये रहेगा omega minus omega naught into t. So this is our final equation now. Now further, how can we get the maximum kinetic energy of the electron? Since we know that for getting the maximum kinetic energy of the electron, we will use that part of this wave which has the maximum frequency, which means maximum frequency means you are giving the maximum energy. If you give maximum energy to the electron, then you will get the maximum kinetic energy of the photoelectron which is ejected from the metal surface. If you see here the frequency is omega naught, here the frequency is omega minus omega naught, but here the frequency is omega plus omega naught. So the maximum frequency which will give the maximum kinetic energy, which will be this part, that is omega plus omega naught, because this frequency term is involved in this equation. So this will eject the electron with maximum kinetic energy. I think it will be clear about on to this point. It's clear, यहाँ तक ये clear होगा. So हमें पता चला अब जो frequency हम इस्तेमाल करेंगे वो होगी हमारे पास omega plus omega naught, but we should keep this point in our minds, but this angular frequency. So for getting maximum kinetic energy, we will find this omega plus omega naught. So how can we find this? So we'll get omega plus omega naught is equal to, our omega is 1 into 10 to the power 15 plus omega naught is 5 into 10 to the power 15. So it will be 6 into 10 to the power 15 per second. So this is our maximum angular frequency. So how can we find now frequency max? Frequency max, that will be equal to omega plus omega naught divided by 2 pi, because we know that omega is equal to 2 pi mu. So we can find this like this. So it will be equal to 6 into 10 to the power 15 per second divided by 2 pi. So this is our maximum frequency which will eject the electron with maximum kinetic energy, Now solving this further, what we will do now, see how can we solve this question further. Since we know that Einstein's equation, which is h nu, which is the incident radiation energy, is equal to psi, that is the work function plus kinetic energy max. So we have to find this term, kinetic energy max, which will be equal to kinetic energy maximum will be equal to h nu minus work function. What is our h nu now? H is Planck's constant, that is 6.6 into 10 to the power minus 34 into our nu is this 6 into 10 to the power 15 per second divided by 2 pi. But this part is in joules. We have to convert this part in electron volt. So we will divide this part by 1.6 into 10 to the power minus 19. So it is converted into electron volts, and our work function is given as 2 electron volts. और ये भी convert हो गई electron volts में. When you will solve this part, it will come out to be 3.95 electron volt minus 2 electron volt. So our kinetic energy max will be, we'll write this part in here, kinetic energy max will be equal to 1.95 electron volt. So this was our question, which we solved in a simple way and easy. I hope you will enjoy this short video. Thanks. Have a nice day.